mathematicians, welcome back to another video. We are going to start a new chapter here on this channel today talking about exponentiation. I have to do a bit of exponentiation theory first before we can come to fractions, so rational numbers. Because you can only really understand fractions if you do understand exponentiation rules. That's why we are going to start with a few episodes of this. It's going to be a huge freaking playlist, and in between we are going to start with the rationals in a different playlist. So I hope you are going to be prepared for that. It's going to be a lot of fun, alright? Recapping all of this, because a lot of students out there have a lot of problems with exponentiation on the one hand and also then fractions on the other hand. So we really have to cover this in depth, and I hope you are going to enjoy those two series. I for myself am really going to enjoy it. I know it now already. So we are going to talk about exponentiation today and what it is. A little introductory thing and the verbal definition of this thing. Exponentiation. It's a weird word. I'm going to write it out for you. Exponentiation. Exponentiation is the act of taking an exponent on a base. It's as follows. It consists of two little things. So if you want to exponentiate something, you have a base a raised to the power b in some way. And today we are only going to talk about b out of natural numbers. 1, 2, 3, 4, 5, blah, blah, blah. Later in the game we are going to talk about fractions, etc. So a to the beef power. However you want to call this thing up here, beef power. That sounds really weird. It's always weird pronouncing this. Now, like I said before, we are raising a base. A is called the base. To some power, but this power is also called the exponent. So b is called the exponent. Just a bit of terminology for you guys. It's important. And the whole thing is just called the exponentiation. In German it's called the Potenz. I don't know if there's something like potency in English. I'm not certain about that. I only know that it's called exponentiation in some way. Raising a to the beef power. But what does it mean to raise something to a certain power? This sounds really powerful, really exciting, but what is it all about? Let us take a look at a certain example. I would like to take a look at 3 times 3. Okay, 3 doesn't matter. You can also do 4 times 4. I don't care. So 3 times 3. We can express this differently. So I want to go a step backwards to natural numbers. I hope you guys remember that I said in the natural numbers that multiplication is basically just a fancy way of writing addition. So multiplication, mathematicians introduced this operation to basically make addition easier on them. So 3 times 3 is the same as adding 3 to itself 3 times. Okay, so this is nothing but 3 plus 3 plus 3. You can make use of the distributive laws. You can factor out the 3. Then we have 1 plus 1 plus 1 is 3. 3 times 3 is going to be exactly 3 times 3. Alright? So just keep this in mind yet again. 3 times 3 was nothing but 3 added to itself 3 times. But what would it mean if we were to upgrade it one step further and say, what is, for example, 3 multiplied with itself 3 times instead of added to itself 3 times? This is where exponentiation comes in. We can rewrite 3 times 3 in a completely different way. 3 times 3 is nothing other than 3 multiplied with itself, base 3, 2 times. Keep this in mind. Think about it. At first we upgraded addition to multiplication. 3 added to itself 3 times gives us 3 times 3. And now all of a sudden we are upgrading multiplication to exponentiation. 3 multiplied with itself 2 times exactly. 3 squared. This is what we call squared. To the second power, to the 2th power, as some individuals like to say. So the 2th power. So 3 squared is nothing but 3 times 3. Meaning there's a nice verbal definition for exponentiation which holds if our exponents are out of natural numbers. If we have a to the beef power, this is nothing but a times blah 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 times a. But b times multiplied with itself. A to the beef power is a multiplied with itself b times a to the 5th power. If you have this in mind for the natural number definition of the exponents, then you can basically deal with nearly all cases of exponentiation. Even if we were to have, for example, a to the 1/2 power, some kind of fractional power, it really doesn't make any sense to talk about a multiplied with itself 1/2 times. Really doesn't make any sense if you think about it like this, but all the rules that we are going to derive later also hold for not natural powers here, and this is really important. Keep this definition in mind for each and every power that we are going to have, this verbal definition, and a lot of stuff is going to fall into your hands one after another. Let us get a bit more grip on all of that. All right, so for example, what is 5 times 5 times 5? 5 times 5 times 5, think about the verbal definition. Well, this is, okay, we are multiplying something with itself a lot of times, or not many times. So 5 is what we multiply with itself, so this is our base. And well, how often are we going to multiply it with itself? Well, exactly 3 times, 1 to 3. So 5 to the 3rd power, 5 cubed. This is what we call cubed. Pretty easy, right? I mean, it does make kind of perfect sense for natural number exponents, and this is basically all you need to know. There's a special case for b being equal to 0, but right now I said we only talk about natural powers, and I introduce natural numbers as 1, 2, 3, 4, 5, blah, blah, blah. A to the 0th power, something completely different. You might not think about it right now because this is a multiplied with itself 0 times. Really doesn't make any sense if you think about this verbal definition. I'm going to make a whole video dedicated to that later. But one other definition, which a lot of students struggle with, immediately follows from this natural number definition. Namely, for example, 7 to the 1st power. 7 to the 1st power is, well, let's think about the definition. This is 7 multiplied with itself 1 times. Well, this is just 7, right? 7 multiplied with itself only 1 time is just 7 in itself. So we can derive a rule here. A to the 1st power is thus a multiplied with itself only once. So this is just a. And here, this is basically it for the introduction. Does make perfect sense for natural exponents. If we get fractional exponents, transcendental or irrational exponents, it's going to be a tiny bit harder, but it's not a big deal. Just keep this in mind, and later a lot of stuff is just going to fall into your hands just because you know the main definition of what this is supposed to mean for natural number exponents. I thank you guys for watching. If you enjoyed this video, please like and subscribe, recommend channel if you want to support the channel a bit more. By those years I create, support the channel on Patreon. Go over to the main channel and watch some videos there on higher mathematics. And up until the next video on exponentiation, I'm wishing you guys a flammable day. Ciao.